Okay, let's give you guys some more practice. So will this integral diverge or will it converge from 0 to infinity? So remember, dead on 0, this whole thing here breaks down. Dead on 0 is undefined, but uh, somehow determine if this will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we're going to break this up. Because dead on 0 it breaks down, we're going to break it up into two different integrals. One from 0 to 1. So we are going to break this up into two separate integrals. One would be from 0 to 1, so 0 to 1, and the other one from 1 to infinity, from 1 all the way to infinity. So now we're going to so here we so this thing here, this is what we want to know. We're going to break it up into two separate integrals, 1, 2. So now let's just look at this one here. Let's look at this one. Later on we will look at this one. So for the time being, let's just look at this one here. So to determine if this thing converge or if it diverge from 0 to 1, we need to compare this to 1 over the cube root of x. Now if you look at this thing here, if you look at the denominator, if you look at this thing here, here you've got one thing adding another thing. If you omit this thing here, if you omit it, then this thing here will be smaller than this whole thing here. Hang on. So let's start again. If you happen to omit this, then we can say that this thing will be smaller than this thing here, because here you're adding an extra tiny bit. Well, if you don't add that extra tiny bit, then this thing here will be smaller than this thing here. And when you cube root it, again, this whole thing here will be smaller than this whole thing here. The whole denominator here will be smaller than the whole denominator here. Now, if the denominator is smaller, then you're dividing by something smaller. So this thing here will be, this thing here collectively will be bigger than this thing here. Hence this thing here is bigger or equal to this thing here. Okay, so now we hang on. So now we know that this thing here diverge, because if you remember, you've got to ingrain this in your mind. 1 over x to the power of 1 looks like this, 1 and 1. So if you've got something smaller than 1 here, it will look something like this. It will look something like this. Now from the integral from 0 to 1, the integral from 0 to 1, well, this is going to converge. This thing here is going to converge. So now because this thing here is going to converge, this being equal to or smaller than this, then this will have no choice but to converge. So it turns, if this thing here converges, this thing must converge. So going back to here, we've got one thing adding another thing. This thing now we know that it's going to converge. This is going to converge, so it's good. Now we need to establish this. So now looking at this, looking at this, look, we now need to determine this now from 1 to infinity. So from 1 to infinity, we will need to hang on, let me think. Yeah, we will need to compare this to this. So from 1 to infinity, let's just imagine this to be the same as x squared. Look at this. Let's just imagine this thing here to be x squared. Let's just imagine this thing here to be x squared. Because if you look at this, if you look at the graph, y equals x, looks like this. X squared will look something like this. So this is 1 here, 1 here. Remember 1. So this is a graph of y equals x squared. This is a graph of y equals x. From 1 to infinity, so beyond 1, x squared will always be bigger or equal to x. So hang on. So if we say this, let's turn this into x squared. Beyond 1, or 1 or above, this thing here is going to be bigger or equal to this thing here. if this thing here is bigger or equal to this thing here, then the denominator here will be bigger than this denominator here. So when you cube root it, then the whole denominator here will still remain bigger than this thing here. Well, if the denominator is bigger, then the overall thing here will be smaller than this thing here. You might have to press pause and think about it, but the point here is that from 1 to infinity, this thing here will always be bigger than this thing here. Well, if the denominator, well, think about it. Overall, this thing here would be smaller or equal to this thing here, because the denominator is bigger. If the denominator is bigger, then the whole thing here will be smaller or equal to this thing here. You press pause and think about it. So now we know that this thing must be smaller or equal to this thing here. Look at this, exactly the same plus exactly the same. That will give you 2 of exactly the same. So now this thing. So we've done this before. This thing here then becomes this. So now this thing here will, well, you should have this diagram ingrained in your mind. 1 over x looks like this. 1 over x looks like this, from 1 here, 1 here. So this is to the power of 1. Anything less than 1, it will look like this. It will look something like this. So from 1 to infinity, from 1 all the way to infinity, this region here is going to diverge. So if this thing here is going to diverge, then when you times by a constant, it's going to diverge. This thing here is going to diverge. The whole thing here is going to diverge. Well, if the whole thing here is going to diverge, this being greater or equal to this thing here being greater or equal to this thing here. If this thing here diverge, then this here will have no choice but to also to diverge, because this thing here is greater than this thing here. So going back to here, this thing we're going to break it up into 2 separate integrals. This integral here is going to converge. We've seen this. Now we've just seen that this is going to diverge. So you've got something that converges plus something that's going to diverge. Then the whole thing here is going to diverge, meaning this thing here is going to diverge, meaning this area here is just going to get bigger and bigger and bigger and bigger. Okay, so this thing here is going to diverge.